Hello and welcome back to the lab. Well, look what we have here. Ain't she a beauty? On the bench today, we have my latest acquisition to my collection, the HP Model 400H Vacuum Tube Voltmeter. I've wanted one of these for quite a while, and I finally got an opportunity to purchase one, and so here it is. Isn't that gorgeous? I love it. I'm excited already. All right, so this is an AC vacuum tube voltmeter, and it reads from 1 millivolt up to 300 volts in 10 dB steps with a beautiful 5-inch individually calibrated mirrored scale linear display meter movement. The frequency range on this instrument goes from 10 hertz to 4 megahertz with a 10 mega ohm input impedance, and it also has an output jack here that outputs 150 millivolts RMS AC for full scale input. So if you have it set to the 1 millivolt range, it has a gain of 150. Set to the 3 millivolt range, has a gain of 50. 15, 5, 1.5. So you get the idea. So there's 150 millivolt AC output can be used as an amplifier as well as a your basic indicator lamp to show that it's been powered. Let's see what else we can see on the back. This is a pretty new one. Hewlett Packard made these from like about 1953 up until 1973. About 20 years they made these things. They started out when everything was tube based. Um, by the 1970s, there were certainly lots of transistorized solid state stuff available, but HP continued to make the vacuum tube voltmeters because of their high quality and desirability. This one has a new style uh, receptacle on the back for the power cord. Most of them have a line cord directly attached, permanently attached to the back of the instrument. So this one must be rather new. And if you look at the serial number prefix of 970, 979A, so that would indicate that this instrument was manufactured in 1969, or maybe a little bit after that, even. It's possible. So, yeah, so this is one of the later ones that HP made of the 400H. Um, got a fuse on the back and a selectable line voltage input. Now, all I've done to this instrument so far is I clean the outside and clean the inside, clean the outside only. I didn't open it up yet. Um, and what else did I do? I removed there were a couple of calibration stickers on here. Um, there was a calibration sticker that said last calibrated in 1979. So we know that 45 years ago, at least, it was working. But that's all we know. It also had some stenciled spray paint on the top from the original owner, which I cleaned off with some isopropyl alcohol as best I could. I scrubbed it very carefully and removed that. There's still a slight shadow of the original spray paint stencil on there, but you can barely see it. And that's the best I want to do because I don't want to do damage to the instrument. I have not powered it on yet, and I haven't opened it up yet either. What I usually do with these things is I don't bother with a variac, bringing it up slowly with a variac, or bother with a dim bulb tester or any of that silly nonsense. These things are rugged and they most likely are still in working condition, even though it's 60 years old or whatever. What I do what I do is I check to make sure that it's set to the correct line voltage. It is set to 115 volts, and I also check to make sure that the fuse is the correct fuse. Let me take a closer look. It's a slow blow. It says it's a 1 amp slow blow, and according to the back here, for 115 volts, it should have a 1 amp slow blow. So that is the correct fuse. As long as we have the correct fuse and it's set to the correct line voltage, there's no reason why we can't just plug it in and turn it on. The fuse will protect it if there's anything shorted or leakage or anything like that. So let's do that. Plug it in. I haven't turned it on yet, so we're going to find out if it works together. Chances are it works just fine. Let's plug it in and turn it on. No explosions, so I guess that's good. The line voltage indicator light comes on. Let's we have some movement. All right, let's set it to 1 volt. Let's apply some voltage to it. Let me see what I can do here. I'm going to hook up my 3325 synthesizer to it, and we'll dial up some voltage and see if we can get it to work. All right. Start with 1 kilohertz, 1 volt RMS. Well, the meter moves. Looks like the meter is stuck. Yeah, looks like the meter needle itself is a little bit sticky. Let's dial it down to 0.3 volts. Yeah, the meter is stuck. Reads 0.3 volts, but the meter sticks. We're going to have to try to take a look at that and service it. But it's basically working. All right. Good. Very good. All right, let me turn it off. The 400H was one of a series of 3 different meters produced by HP in the 1950s and 60s. Here we see an image from the 1967 HP catalog illustrating all 3 meters. The one on the far left is the 400D, which is the basic model in this series. It has a 2% accuracy and a 3.5-inch standard meter movement. The 400H is the one in the middle, which is the same one that is on my bench today, and that has a 1% accuracy with a 5-inch mirrored scale, individually calibrated meter movement. So the H is the high accuracy, high precision version of the 400D. On the far right is the 400L, which is the logarithmic version of the 400D. It has a decibel scale at the top instead of at the bottom of the meter movement, and the decibels are in a linear fashion, whereas the volts are displayed in a logarithmic fashion on the 400L. All right, so let's open it up and take a look inside. Oh, so now comes the disclaimer part of the video. First, you want to unplug it. This is a tube instrument, and as such, it's got high voltages, in fact, lethal voltages inside the instrument, and perhaps there may be lethal voltages in the instrument even when it's unplugged and turned off, because the capacitors may hold the charge, and they are very high voltages inside there to operate those tubes. So if you don't know what you're doing, please let someone who does know what they're doing work on your vacuum tube voltmeter. You don't really want this to be the last voltmeter you ever got a chance to work on. So that's the little caveat there. All right, so let's open it up. We have the two screws on the back. These are standard Phillips screws. Hewlett Packard went with positive drive screws, but I guess it was a little bit after this because these are standard Phillips screws. Seem to be 832 American SAE screws, 832s. Pull the two screws out, and the back cover should just pop off, or the it should pop out from the front. Push it out. Yep, there we go. We'll take a look at what's inside. Oh, one thing that's inside is a lot of dirt and dust. Of course, we have all these louvers on the case, so I had a lot of dirt and dust to come in. Yeah, wow. Seems to be in really good shape. We have all these can electrolytics. I will bet they are all just fine. HP used really high quality electrolytic capacitors, and I will I will test them all, but I imagine they are all just fine. We have these poly caps, which also I'm sure are fine. They're not going to need to be replaced. Oh, okay. There's one thing I see here that I might want to look at replacing, the selenium rectifier. Clearly it's working, so I don't have to immediately replace it, but that might be something I want to look at replacing. We have these Bumblebee or Black Beauty style capacitors. There are a couple of them in there. I will test them for leakage, but I'll bet they're okay as well. But you know, HP in general did not use cheap components, especially back then. So we might not have to do any servicing at all to this instrument, besides blowing the dust out, cleaning it up a little bit. I probably will end up replacing the selenium rectifier with a silicon, 4 diodes or something. We'll take a look at that. But I'm going to have to pull this meter movement out and try to figure out why it is sticking. Now, I do have an operating and service manual on order for this thing, but it hasn't come in yet. So I guess we're going to have to wait for that to maybe finish the repair on this instrument. I'm sure that'll be here in a couple of days. Then I can finish up this video. In the meantime, I'll just take a air hose and blow out the dust, and maybe a paintbrush or something, and scrub it a little bit. See if I can pull this meter movement out and maybe try to open it up and figure out why the needle is sticking, because it's in the meter itself. It's not in the electronics of the instrument. It seems like all of the electronics are working. I will probably have to get in here and take a look at the range switch and clean the contacts if necessary on the range switch. I don't want to get too carried away with any repairs or any service before I have the manual to really let me know what's going on with this instrument. But it's really nicely done with a combination of standoffs and point-to-point wiring and a couple of circuit boards in there as well. Yeah. Lots of vacuum tubes. 1, 2, 3, 4, 5, 6, 7, 8, 9. Looks like 9 tubes. Got a rectifier tube. I think that's a rectifier tube. 6AX5. I believe that is a rectifier tube, as well as a selenium rectifier. So a couple of different things going on in here. I don't have the schematic yet, so I don't really know what's going on. These tubes say HP on them, Hewlett Packard. So they probably all the original tubes. This one, I don't know. Let's take a look. I don't even want to pull it out. Um, yeah, it looks like all original tubes from 1969. I wonder if I can see a date code in here somewhere. I'll take a closer look. Maybe I'll find a date code. There's probably a date code on that electrolytic right there. Let me see if I can see it. Well, I don't see a date code offhand. Take a closer look, see if I can find a date code or something. Get this thing cleaned out a little bit on the inside, and before you know it, we'll have a perfectly working instrument. Okay, so I have very carefully removed the 4 mounting screws that hold the meter movement in place in the instrument and unsoldered the 2 meter terminals. And I don't know if this shows on camera, but if I look very closely, um, the needle of the meter, when it's at 0, is completely free of the face of the white face of the dial. All right, but as the meter gets close to the full scale, um, it tends to stick near the 1 on the on the on the dial. Now it seems like the needle itself is not actually bent, but the face of the white face of the meter with the graduations on it seems to be slightly warped in this corner, in this upper right corner, so that the needle hits that face near the 1 and gets stuck there. And if you tap it, it comes back. But if you don't tap it, it stays where it last landed. Um, so I'm going to try to see if I can open it up and maybe coax this back into its correct position without messing anything up. It's going to be a tricky operation, but I can do that. I guess I can do that. I can try it anyway. Um, there's an individually calibrated inspection label here, which I'm going to try to carefully peel off because it's covering up the screws that hold the meter movement together, and try to preserve that so that I can glue it back in place once the repair is completed. Oh, by the way, I did find date codes on all of the tubes, and all of the tubes say date code of 1970, the mid to late 1970. So that's when this instrument must have been manufactured, around late 1970. Not really 1969, but close. All right, so let's see if I can get this back of this meter open without messing anything up. It's going to be a tricky surgery, but I'm going to try my best to do it. Well, I don't have a lot of skill as a watchmaker, but I managed to get it apart without damaging anything. It was a little tricky. Um, Trying to very carefully bend the corners of this dial uh, backwards so that they will not rub against the needle. Um, it's so far so good, but I don't know if I will be successful in the end. But I'm going to still work at it. Well, the meter is back together. I don't know if I have fixed the problem, but we're about to find out. Let's put it back inside the instrument and see what happens. All right, so after reassembling everything, I think I have fixed it. There it is with power applied, with the input applied. Let's turn it off, and it goes right down. The needle is no longer sticking. Actually, the instrument is reading about 10% high, so it's way out of spec. But I'm sure I must have bumped something in the calibration when I was brushing the dust out of the inside of it. I must have changed something in the adjustments. But I don't have the manual yet, so I'm going to have to wait for that manual to come in before I can redo the adjustments and bring it back into spec. But the needle is no longer sticking, so I fixed the biggest problem with this unit. Very good. All right, let me put it all back together and wait for the manual to come in before finishing up. All right, so that will do it for part 1 of this video. When the manual arrives, I will go through the complete realignment procedure and performance test of the model 400H vacuum tube voltmeter, and maybe we'll put it to use with a couple of applications, make some measurements the way they did things back in the 1950s. So thanks very much for watching. Please stay tuned for part 2. Please like and subscribe, and I will see you soon. Thanks again.